What is up, guys? Fire here from usdudes.com. Welcome to another course. I call this plane fighter, plane crasher, plane game, whatever you want to call it. But anyways, I know you don't like to hear me speak like this. Let me just introduce you to the game. So when we hit the play button, you will hear now the background music. I'm going to shut up. There you go, you can hear the background music. I'm also going to lower now the volume. We have here three buttons. We have options, quit, and play game. Options will not do anything. You will have an assignment to configure that however you want to configure it. Quit will do, or it will quit the game, but you need to be on your device, be that mobile or be that a computer. But play game will play as the game. So when you click the play game, you see this nice little slider animation going towards the plane, and now the plane is going to take off. When the plane takes off, we will see now the enemies, the pickable items, and we can go from one island to another. You see now already we have the score. We're counting the score. You see this balloon is one of our enemies. You see those circles that are going to boost our score and boost our speed. And also you have noticed that now just a plane has passed us by. This was a score booster and this is a speed booster. So when you collect the speed booster, we will move faster, as you just saw. And now you can see that we are going very fast, and we passed one of the islands, and we have spawned another island over here, if you just noticed, but you probably did. I mean, you look at those things. At the top left corner, you will see this slider, which is a fuel that is lowering. When it gets to 0, we will die. But here is one of these fuel tanks that we can collect. But we need to be careful not to hit one of these obstacles. So when I collect the fuel tank, you see it increased the value of the fuel. If we get touched by the planes or by one of these balloons, we will die. And again, also, if the fuel gets to 0, we will die as well. So let's see how does that dying work. And if I touch one of these balloons, bam, I touch the balloon, you see, and now I have crashed and the game has restarted. We can click on play game to play again. The game looks pretty simple, but it's complex. A lot of things are covered here. Anyways, Fire here from usdudes.com. Let's jump in and create this cool game. And what else can I say? See you in the next video. Let's get started with our game, and the first thing that we need to do is create the project. And I have Unity Hub here open. If you don't know what Unity Hub is, basically it's a place where you can manage all your projects and all your Unity versions, as you can see. Now, if you don't know how to install it, just go on my YouTube channel, type Awesome Tuts Unity Hub, and you will see the video. But basically click here new, and it will open this window here to open or create a new project. The same thing goes if you are only using a standalone version of Unity. So if you're using one version of Unity, I'm going to use 2019.2.4. This can work with 2019.3 as well. So it's the exact same thing. And when you click on the icon, you will open this settings right here. And then here, give the name to your project. Here is the location where you want to store it. Click 3D because it's a 3D project, and click on create, and it will create the project. So again, I'm using 2019.2.4, but you can also use 2019.3 and it will work as well. So moving forward, this is what you will see when you create the project. Of course, we have the scenes, we have the regular stuff when you create a new project. Now below this video, you will see a link to download the assets for this course, and you will also see a link to download the complete project that is the finished project for this course. Download the assets and open them, and this is what you will have in the assets folder. So select everything over here that you have in the assets folder and simply drag it over here in your Unity editor like this. So simply drag it over here and release the button, and of course wait for Unity to import all of this. So I'm going to cut out the video. It will take a moment or two because we have a lot of assets. So I will get back to you when this finishes. And here we are. Wow, that was quick. Well, it was quick for you, but it was not quick for me. Anyways, moving forward, here we have some errors in the console. Simply click clear. That's all there is to it. No matter which errors or warnings you see in the console, it will not affect you following this course, and it will not affect our game. So you can safely click clear, and there you go. So moving forward here below, we will have scenes 1, 2, and scenes folder. So as you can see here, we had our own scenes folder. We imported scenes 1, and we have scenes 2 folders. So don't worry about that. That's only the naming of the scenes, but basically we want the scenes 2 folder, and we want this main game scene because it's already prepared. If you cannot find it, click on assets and go over here, you see, where is the search bar, and click on the search bar, simply type main game like this, and it will find it over here. And then what you can do, you can select the main game here. So simply select it like this and then go and click this X over here in the search bar and it will take you where the main game is. Double click on the main game scene and this is our game scene. So I have prepared it. This is our water. This is everything over here. Let me just double click on the plane and find it. Let me just scroll or zoom a little bit down to find our plane. I have prepared everything and the reason for that is because it's tedious for you to watch me drag and drop these assets inside of the game folder. You can explore the project on your own. You can click on the plane. If you want to check out the 3D models, that's easy to do. What you can do is you can explore the project over here. You can find where the plane's mesh is. So going over here, you can find where that mesh is, click on it and you will find it over here, so on and so forth. I'm not gonna go through all that because again, it's tedious and it will just take time for no reason. There you go. So we have here our plane, we have the island, everything is prepared and I just wanted to show you that. So you can also click and explore the island. You can see everything that we have here in the island. You can move it up and down, so on and so forth. Again, for those of you guys who will get mad for some reason, you can just explore these 3D models that are inside and try to recreate this on your own because again, it takes a lot of time for me to position all of this here and I will just be dragging and dropping and I don't know what I would say. I will be like, okay, move this here, move this there. It will be boring for you. You get the point. So I encourage you to explore the project. So explore this train. Why train? The plane, not the train. Plane. Explore the island, so on and so forth. And you can see how everything is set up. You can also recreate this on your own. So you're free to do that. And I encourage you to do that. Anyways, this is for the first video. Just importing this, getting this out of the way. And starting from the next video, we will start to program our plane and start to program everything, so on and so forth. So I will see you guys in the next video. Before we proceed with our game, I want to discuss one thing, and that is a lot of people ask me how should they create their game in terms of should they first create the player or the main menu or the enemies? Where should they start to create the game? And the answer to that question is not general. It depends on your game. As you saw from the preview of this game, our game starts, you see the main menu, you see the plane, and when we click on play game or start game, then the game starts playing, it zooms in on the player and the player takes off. In this case, the player is the plane. So the most logical thing to do in our game is to start creating the main menu because it is connected to the game. When we hit play, then the game starts playing. We cannot create the gameplay mechanics. I mean, we can, but it's easier when we have that in place. So I'm going to start with the main menu. So I'm going to right click over here, go under UI, and I am going to create a canvas. And for this canvas, I am simply going to call it main menu like that. I am going to change the render mode from screen space overlay to world space. That means that here inside of this Unity world space, everything that you see now that I am rotating here, this is world space in Unity. So our main menu or our canvas is not connected to the screen space that you see over here. Instead, it is connected in the world space, similar like our plane is. So now what I'm going to do is I'm going to position it at 168 for the X. For the Y, it's going to be 38, and for the Z, it's going to be negative 2000, so 2244, 2044. I'm also going to set the width and the height, so it's going to be full HD, so 1920 by 1080. But it's pretty large right now. As you can see, I know you see this is one of the lines over here, if you can see that. So what I'm going to do is rescale it. So selecting the main menu canvas, here we have the scale, which is currently at 1. So I'm going to set it at 0.0 or actually 0.106, and here also 0.106. So here we need to say point, and also here 0.106. So it's 0.106, 0.106 for X, Y, and Z, and there you go. And over here, we're not going to touch anything, so our canvas is this right here that you now see. So this is our canvas. And it's much smaller, it's this right here. You see it, I don't have to introduce that to you again. So now moving forward, and we can name this bad boy over here like main menu canvas, and inside of this one I'm going to right click and create an empty game object, and this one is going to be our main menu holder because this is the bad boy who is going to hold our main menu. And I'm simply going to reset his width to 353 and height 356. So this is going to be our holder for the main menu, and now we are going to create our buttons. So selecting the main menu holder, right click on it, go under UI and create a button. Let me just find over here. Here it is. So this is our button. Now, of course, this button, I'm going to select it. This is going to be our start button. So start button, and I'm going to resize it, reposition it. So I am going to set here the anchor to stretch. So we're going to set it to stretch, and let me just click on the drop down list for the rect transform. So over here for the left, I'm going to say 42. For the top, it's going to be 13. And for the right and the bottom, so right over here, I'm going to say 32. So 32. And for the bottom, it's going to be 253. So this is our button. And there you go. Now, what I'm also going to do with the button is I am going to change the color. So I'm going to go select the button and go over here where we have these normal colors, highlighted color. So the highlighted color, I'm going to set that to be 3FCBDF. So this is going to be the highlighted color. I am also going to change this normal color, but basically I'm just going to change the alpha over here. So I'm going to set it to 197 to make it a little bit transparent, and basically that's all there is to it. So this is going to be our button. And of course we do need to set the text, and the text inside of this button is going to be start or play game. So play game. I'm also going to change the font from Arial. So click on the circle over here for the button, or actually for the font. So you see this little circle where I have pointed this arrow to, and over here we're going to select this Caviar Dreams. So again, let me just click on it, Caviar Dreams. I'm hoping that I'm pronouncing that right. I don't care. I'm also going to set the font size to 50, and I'm going to set it from normal to bold. And there you go. This is all there is to it. This is our play button. Similarly, we are going to have another one. So just Control D to duplicate if you're on Windows, Command D on Mac, and this one is going to be our options, and everything is going to be the same except that we are going to change the position. So 42 for the left, for the top is going to be 133, so 133 for the top, 32 for the right, and our bottom is also going to be 133. And of course, change the text. So here for the text, I'm going to change it from play game to options. So options. And again, one more time, Control D to duplicate these options, and we're going to have our quit button, and there you go. So when it comes to the quit button, we are going to set the left 42, the top is going to be 258, the right is going to be 32, and the bottom is going to be 8. There you go. And of course, from here, we are going to change this to quit. And voila, if I go here inside of the game, this is our main menu. So we have our play game or play game button, options, quit, and they reflect nicely on this water. And by the way, this water is over here. You see water pro daytime. You see we have the water script. Everything is enabled. Don't worry about that. Everything is set up and it's nicely being reflected over here. So if I hit the play button, let me just lower my volume because we have background music playing. And there you go. Look at the water, look at the buttons. We can click on the buttons, yada, yada, yada. You get the point. But of course, we cannot do anything with the button. And what I'm going to do for this, so for this video as well, we are going to create our main menu controller, simply some basic script that's going to handle the pressing of the buttons. So let's go here inside of our scripts folder, which is already created. I'm going to right click and create a new folder, which is our UI to handle our UI. And over here, I'm going to right click and create a new C# script, which is going to be our main menu controller. There you go. And I'm going to, well, simply double click on it and open this bad boy in the Visual Studio. And I'm also going to select the main menu holder. So let me just go over here. Come on, Unity, open the editor and select the main menu holder, and I'm going to attach the script on him. And over here, we're simply going to have functions that we are going to use to attach on these buttons. Now this over here is our class, or the last curly bracket that is connected to the class. I am going to create over here for the main camera. We are going to do that. So later on when we create the main camera, which is going to happen from the next video, don't worry about that. But we're going to have here our public void. So public void play game like this. And here we are going to play the game. So I'm simply going to print and display that to the user. So play game, and below we are also going to have public void quit game like this, and over here we are going to print quit game. So let me just copy this and paste it, and I'm going to say here quit game. And of course, if you truly want to quit, you're simply going to call application quit like this. Not quitting, quit. Give me the correct autocomplete. Okay, so now I can go back over here and I can select the start button and the quit button. Come on, start and quit, and go over here on click. So when you select the button, scroll down here for the on click and click on the plus button over here. And now we are going to drag the main menu holder here because he holds that script. So drag it over here, and from the drop down list here from the functions, for the start button, I'm going to select main menu controller, play game, and for the quit, from here, I'm going to select quit game. There you go. I'm going to hit the play button, and let's go here in the console. So click on the console. Let me just clear everything over here. Click play game. You see play game is working. Quit game is working. When it comes to options, your assignment is the following. Create some options where you can lower the volume. That is one thing. You can think of something else that you can do. Maybe create the difficulty of your game, hard, normal, whatever. I'm not going to do that. That's your assignment because I want you to practice. But at least do that for our background music. And here is our background music. So you can get the audio source and manipulate the volume of it. But you can set that over here in options using the slider, whatever you want to do. But you can fix that, creating another UI maybe for music options. I already gave you enough hints for you to finish this on your own. Anyways, Fire here from OzDudes.com. That was your assignment, and I will see you in the next video when we start to program our camera. Now that we have our main menu, let us program the camera, because from our play button, or when we press the play button, we are going to start to move the camera. And here is our main camera, so this bad boy over here, and it's positioned where it is supposed to be at the beginning. So what I'm going to do here in our scripts folder, I'm going to create a new one, because we're only going to have one script for the camera. So I'm going to right click here, create, and a new C# script, and I'm going to call this bad boy main camera. Now, of course, as I already said, and it's opened right away, what just happened? I don't know. Anyways, let me go back in Unity, and we are going to attach the main camera script on the main camera. So drag and drop it on the main camera, double click that bad boy, and open it in our Visual Studio. So over here, I'm going to tag this as class, just so that we know that it is a class, or actually the last curly brace or bracket inside of our class. So at the top over there, I'm going to say private game object player for our player game object. And I'm also going to create a public bool game started. And this one, I'm going to hide it in the inspector. Now, what's hide in inspector? Well, if we don't use this hide in inspector, if I just comment it out, and if I go back over here, if I select the main camera, you will notice here at the main camera, so come on, you see here, we have the game started, which is a boolean. We can check it or uncheck it. If I use hide in inspector and go back now, let us just wait for the script to load. You will see that this game started will now go away. So there you go. So it is public, it is accessible anywhere in other class, but it's not visible in the inspector panel. That's all there is to it. Now next I'm going to have a private bool, which is going to be camera lock to player. By default it's equal to false. Now when I say default it's equal to false, you can either do this, you can say it's equal to false like this, and this is the exact same thing, because if you remove this here, the default value of a boolean variable is false. So this game started is false, and this right here is false as well. Next, I'm going to have over here a private vector 3, which is going to be current angle of the camera. I'm also going to have a private int, which is going to be our camera type, and by default, it's going to be equal to 0. And even if I remove this, it is going to be 0, but I'm going to set it for this integer. And what is the camera type? Well, we will see later on, or actually what you saw from the preview of this course is that you can change the angle of the camera where it is looking at the player. So it's going to be camera type 1 and type 2, but we will fix that later on when we create the player controller and all the good stuff. Next, I'm also going to have over here a public vector 3, and this one is going to be camera menu position. So camera menu position, and this is going to be the position of the camera coming close to the player. So 174 is for the X, 33F for the Y, and negative 2314 for the Z axis. This is again, and this is no magic number that I made up or whatever, and let me just move this down. This is no magic number that I made up, this is just testing. So these numbers are working for me, which means basically when we press the play game, the camera will come close to the player or the plane in this case. So it will come close like this, as we saw from the preview, and I measured that or those coordinates at that point, and these are the coordinates. It's simple as that. Next, I'm also going to have over here a public float, which is going to be our camera tilt, not tilde but tilt, and it's equal to 10 by default. And we are going to have a private bool, and this one is going to be camera and screen is equal to false. But basically this is if you want to add an end screen, this will be up to you. And over here, add player controller, but this is later on when we actually create our player controller. Now, before anything happens, what we are going to do is over here inside of our start function, I'm going to say current angle is equal to transform.ELERAngles to get the default of the current angle. We will see for what we are going to use this, of course, when we follow the player and so on and so forth. Transform.position is going to be equal to camera, so camera menu position. So this is the position of the camera on the main menu, and of course get the player controller, get player controller. But before we do that, we need to get the player, which is this bad boy over here. So we can get the player, which is going to be equal to game object find with tag. Now the player is unfortunately tagged here. Let me just go back and select the transport plane green, which is our player, and I can click on him, and we have the player with lowercase p, but we're going to set it to uppercase. So player with uppercase, this is a default tag, and these tags that you see here, game controller, music island, and player, these are imported with the assets. So the player with the uppercase p, because usually I put my tags with uppercase, so player like this. There you go. So we have everything we need. But of course, before we start doing anything, we first need to lerp the camera. So over here below the update, I'm going to create a void lerp camera to game start, like this. And over here, lerp camera to game start. What's going to happen in this function is that we are going to come closer to our player. And over here, I'm simply going to say transform.position of the camera is going to be equal to new vector 3. And over here, what we are going to do, I'm going to hit enter 2 times so that we can go here below. So for the X position, I'm simply going to say matf.lerp. And lerp, I will explain in a second what it is, from transform.position X towards our player.transform.position.x in time.delta time divided by 1.5f. And of course, then we need to say comma over here because we have y and z. So copy this here, go below, paste it, and go below one more time and paste it. But over here, it's going to be from transform position y towards player transform position y, but we're going to add 20 to it, so add 20 units to it. And of course we are going to divide that by delta time, or actually in delta time divided by 1.5, and over here it's transform.position.z towards players transform position z, but minus 80, and again in time.delta time divided by 1.5. So what the hell is happening here, teacher? I don't know, I'm so confused. And we can move this, so we can move it like this. matf.lerp, if I hover over, it says linearly interpolates between A and B by T. What this basically means is we have point A, we have point B. Point A is our transform position, and point B is this over here, player transform position. So lerp is gonna go from this point to this point over here in this timely manner. This is all there is to it. So it's going to smooth move from this position to this position. That's all there is to it, basically. Moving forward, our current angle is going to be equal to new vector 3, and we are going to do something similar over here, open close curly brackets, or actually normal brackets, not curly. And we're going to say mathf dot lerp angle this time. So we're going to lerp the angle, and we are going to lerp from the current angle dot x towards our camera tilt, and we're going to do that in time dot delta time, and I'm going to divide that by 1.5 f. And of course we do need to copy this line of code and come over here, paste it, come again, paste it, because we have x, y, and z. And for our y, we are going to say from current angle y towards, but not the camera tilt this time, we are going to lerp to 0 in time dot delta time divided by 1.5 f. And for the z, we're going to lerp from current angle z towards 0, so towards 0, but we are going to divide the time dot delta time by nothing. So over here on the first two, we're going to divide it by 1.5, and over here we are not going to divide it. And by the way, the time is, well, this time over here, this is the time interval, so time dot delta time divided by 1.5. And how did I get to these numbers? So basically I just tested out. You put random numbers until you have a number that actually works. That's all there is to it. There is no magic, there is no math there. I'm not some, physicist or whatever. So that's all there is to it. Now over here we're doing the exact same thing as we did here, but we're just doing that for the angle. So if I hover over, it says same as lerp. You see? Let me just go over here. Same as lerp, but make sure the values interpolate correctly when they wrap around 360 degrees. What does that exactly mean? I'm not sure, to be honest. But basically, again, the same explanation. It will go from this value to this value in this time interval. It will smooth it out. And that's all we need to know. What does it mean to smooth it out? Well, think of it like this. Let's say we have a straight line and this is a smooth line. If we want to go normally and the game looks normal and the camera looks normal, we would go like this. But if it's not smooth, it will look something like this. Basically, I mean, it's not like 100% like this, but I'm just trying to paint the picture to help you understand this better. That's all there is to it. Next, we are going to say transform dot Euler angles is equal to the current angle. And then, well, basically we did over here, current angle, we set that value to the transform Euler angle, so we changed the angles. And then the last step is to test if our transform dot position dot x is greater than our player dot transform dot position dot x minus 0.5 f. So if the camera's current position is greater than the player's x position minus 0.5, then we're going to say over here game started is equal to false. Next, we're going to say camera lock to player is equal to true. And over here, we are going to call player takeoff animation, which is going to make the player take off and move forward and whatnot. That's all there is to it. Now we are going to call this in the late update. So in our late update, it can be private void, but usually I put it only void. And we're going to call it like this, but we do need to do one more thing, and that is we are going to do this. We are going to say if, so let me just move this. If our game started, then we are going to call lerp camera to, you see, lerp camera to start. Or we can do it over here. So we can simply put all of that. So we can copy this and we can simply say if game started like this, and we can place all this code inside as well. So over here I can say if game started, so that we don't have this if statement inside of our late update. So simply I can put it like this. Now what is the difference between late update and update? Update is called once per frame, so as late update as well. But the difference is our late update is called after update has finished. What does that mean? Well, depending on if we have 35,000, a million frames in a second, it doesn't matter. At the beginning of each frame, update is called, and any calculation that has been done in the update we can use it in the late update. So for example, imagine we have, for example, int A and int B, and we have the sum C, which is actually int sum. If we do something like this, sum is equal to A plus B. So by the time late update starts, this has finished, and we can use sum as a value over here. So basically, as I said, late update is called at the end of the frame. So every frame, but at the end, after update. That's all there is to it. Now, if I go back over here, we can run this, but nothing is going to happen because we need to trigger our game started so that it actually works. So if I do something like this, if I hit the play button, we will see that, well, our game will run, but nothing worse. I can hit the play button and we hear the background music. I need to lower my volume. But what I'm going to do is go back in our main menu controller. And over here at the top, we are going to create a private main camera. And there's going to be our camera script or main cam, simply like that. And inside of our start function, and it can be private void. For some reason, I hate to put it private. I don't know why, probably me. But anyways, if it's only void, by default, it's private. So by default, these two are the same. If you type private void or if you don't type it, it's the same. So we are going to say main camera or main cam. So main cam, it's going to be equal to game object. So game object find, and the game object needs to find our main camera. So main camera, this is the name of that game object, dot get component main camera component. There you go. So what the hell is this here? Well, we did this already in numerous of courses. The name of the game object that we want is main camera. You see main, then space, then camera, capital M, capital C. So over here, we're doing the exact same thing. Game object, find us a game object in the scene with the name main camera and get from it the component main camera. So now what we can do is remove the print from our play game, and we can simply say main cam dot game started is equal to true. Because again, by default, we already saw, let me just go back over here. By default, the game started is equal to false. When it's true, we will start lerping towards the player, and when we get to this point, we will set game started is equal to false, and we will stop lerping. That's all there is to it. Let's go back and test it out. So let me just clear everything. If I hit the play button, so now when I click on play game, the camera will start lerping towards the player. So if I hit the play game, you see, bam, we lerp towards the player, and now we are going to stop lerping when our position gets to the position where the player is. And if you want to test that out, we can simply do something like this. We can say print, not pront, it's print, and we can say here, camera stop lerping. This is just to, again, test it out. If something is not clear, even though we already explained all of this here, please ask in the comment below the video, because all of this is basic stuff. If you went through any of my other Unity courses inside my Game Development Academy, this will be easy peasy lemon squeezy for you. So let's go back over here. If I hit the clear button, then hit the play button, then hit the play game button again. So I know it's a tedious project, but you're creating a game. It's not like you're eating or something that's, you know, simple. So now we will see here in the console that eventually when we stop camera, stop lerping, there we go. Voila. Next step is to call and actually make our player take off. Again, if something's not clear, please ask in the comment below. Until then, fire from us as I come. I will see you guys in the next video. Now that when we click the play game button, our game starts, we are going to program the plane taking off. So let's go over here in the scripts folder. I'm going to right click and create a new folder for the player script because, well, we want to store player scripts here. It's, you know, a no-brainer. Anyways, create a new C# script, and I'm going to call this bad boy player controller. And we are going to select this transport playing green, which is our player, if you're following the course so far. Just kidding. But anyway, select him, and for some reason, sometimes, you know, you see Unity bugs, whatever, I don't know. My computer is pretty good, so I don't know why this is happening. It's not important. Anyways, here we are. So let me just go over here, let me just tag the class, give a little bit of space over here, and let's go at the top. because we need to declare a couple of hundred variables. Just not 100, but a lot. Anyways, we are going to say animation here, anim, and we are going to say private camera, and this one is going to be our main camera like this. We're also going to have a private rigid body, so private a rigid body, which I'm going to call my body. And moving forward, we are going to have the velocity and yada yada yada. So this one is going to be our public float forward velocity. That's going to be equal to 100f. We are also going to have public float minimum speed, which is going to be equal to negative 1,500. And since I have a lot of variables to type out, instead of you watching me type it out, I'm going to pause the video now, type all the variables, come back and explain what every variable is, and then you can copy them because it's just typing out variables, okay? And we are done. Wow, that was quick. Well, for you, but for me it wasn't. It was very painful. So now you're going to type this out and you're going to suffer, okay? But anyways, we have the animation here for obvious reasons because we want to animate the plane. Next, we have the main camera because we're going to get a reference to the camera. We also have here a rigid body, which is the body of the plane. We also have the forward velocity, minimum speed. You can guess what they are. So forward velocity for forward, moving forward, that is. Public float, maximum horizontal speed and current horizontal speed. It's obvious. So what is the horizontal speed and what is the current? This is the maximum. What is the current? Same for the vertical speed. The current rotation and the current angle of the plane. We have the borders because we are not going to allow our player or the plane to go above or below these borders. So this is what these are for. Here we have the bonus horizontal speed and the boost. This is when we boost our plane, when we pick up a collectible item that is going to give us a boost in speed. This is our starting speed. This is a variable that will indicate if we can move or not. This is our stored velocity that we will initially store, and this is the boost values that we are going to use to boost our player. And what I can do over here, I can add an underscore here as well because all these variables start with the speed boost name. So speed boost value, timeout, timer. So when we have an underscore between them, we can differentiate them more easily. So what's going to happen now is here below in the awake function, and let me, for some reason, I love to remove this private. I don't know why, don't judge me, I'm weird. Anyways, our anim is going to be equal to get component, and this is going to be our animation component because we need the animation component. Our body is also going to be equal to get component rigid body because again we want to get the rigid body component as well. Now my body is kinematic is going to be equal to true. What is kinematic to true mean is that gravity will not affect our body and physics forces. So it will not be affected by gravity. Simple as that. It will have a rigid body, but again, it will not be affected by gravity. It will not start to go down. Next, our current angle. So current angle is going to be equal to my body dot transform dot Euler angle. So we are going to get the current angle from the Euler angles of the transform. And when it says Euler angles, it's basically, you see, rotation is Euler angles in degrees. Basically, think of it just as a rotation. Ignore the Euler, it's just the rotation of our game object. And I don't know what was that just now. Anyways, moving forward. Next, we have our main camera, which is going to be equal to, so main camera, again, I hate this, main camera, thank you, giving me the correct autocomplete, is going to be equal to camera.main. So we're going to get the main camera, and when you say camera.main, it is going to get you the camera in your game that has this tag, main camera. So let me just select the main camera over here. You see the tag over here, main camera. So when you type main or camera.main, the first enable camera tagged main camera. You see, this is what we are getting. And our stored velocity is going to be equal to new vector 3 and 0 for the f or x, 0 for the y, and start speed for the z axis. So we want to move our game object or the plane forward. Now, what we need to do is the following. I need to go back here and below the update before we start to move our plane and so on and so forth, we are going to do this. We're going to create here public void, and this one is going to be start takeoff. And this is going to be the takeoff animation that we are going to play for our plane. And in order to play it, we're simply going to say anim play. And over here, we need to add the name of the animation. The name is takeoff. How do I know this? Well, if I go back here in our game, and I will need to select the transport plane green, which is our player. So select him, and over here, you will see his animation. You see over here is his animation, and he has the animation called takeoff. If I click on that animation and I go over here, this is that animation. If I go into the animation tab, this is that animation. And you will notice here at the last frames. So here we have 2 frames. If I go over here, this is 1 frame, enable score count. We are going to remove this right here is animation event, so select it and delete it, but we need this one. So this animation event called resume, this is the one that we need. And what the hell is that? Well, I covered animation events in my other courses. I also have a special video on my YouTube channel covering only animation events. Basically, you see this over here, these are all frames. So these are the frames. You see we have 600 frames, and if you're wondering how did I create these frames, well, basically you see over here you can just experiment with this. This is not the first time. If I select my transport plane, let me just see if I can, yeah, I can preview this. So pay attention to the plane over here. Look at the plane, he's selected, and let me just hover or move over here. So when I move these, you see it is taking off. So this is how I animated it, basically, with the rotation and the position. It's just that. It's nothing else. It's just moving the rotation and the position. That's all there is to it. This is nothing complicated. If you followed any of my other Unity courses, which I recommend that you do, don't follow this one as your first course. I have a guideline in my Game Development Academy telling you which course to follow first. But this is how I created. This is basic stuff. So this is basic stuff, how to create this animation. That's why I created it. That's why it's prepared, so that we don't lose time. Anyways, you see these frames over here, and at the last frame, or basically before the last frame over here, when we get to the frame 692, it will hit this animation event, which will call a function. Pay attention over here. You see we have a function called resume. And it says over here it's not supported, but why? Well, because over here below we do need to create it. So it's going to be public void resume. So let me just go over here, resume, come on, resume, there you go. So now it will be supported because now we will have that animation function, or actually this function inside of our, you see now, when I go over here, if I select it, there you go. We have the resume function, you see? And the reason why we have it is, again, because we declared it over here. So we declared this bad boy over here. Now, what's gonna happen? First off, we do need to go back here in our main camera. You see over here, we need to call the takeoff for the player. This is where that is going to happen. But in order for that to happen, we do need to go here above. You see, add player controller, and I added here a tag. We're going to create a private player controller, which I'm going to call player controller, like this. And simply inside of our start function, we are going to say player controller with a lowercase p, player controller, is going to be equal to game object. And over here, I'm going to say dot find with tag, and I'm going to find with the tag player. And I'm going to say get component and get the player controller component. It's simple as that. That's all there is to it. So basically what we are doing over here is we are getting the player controller with find with tag. You see this over here, find with tag, get the player controller component. It will find the game object with this tag and get the component player controller. So over here you see add or call player takeoff animation. This is what we are doing. So call player takeoff animation. Over here we're going to say player controller. Again, why with the uppercase dot start takeoff. You see over here, start takeoff. It is going to go here inside of our player controller. Let me just find where he is. And it's going to call the animation to play the takeoff animation. And if I go back over here, select the transport plane green, we will see that we have one animation over here, which is our takeoff. So now when I press the play button and when we click the button to play the game inside of our game now, so play game, we will see now that our plane is going to take off when we reach the end of the animation. So pay attention and bam, you see it went to take off. Now over here we have this wrap mode that is telling us, let me just select here. So select the takeoff animation, select it, and over here for the wrap mode, I'm going to set the default. That will simply remove this error. I'm not 100% sure why this error appears or what it is 100%, but setting it to default should fix it. So if I hit the play button again, when we reach the end of the animation, we will call now our plane to take off. You see no error over here being displayed and our plane took off. And pay attention, the plane is over there. It will of course stop because we are not moving it anymore with the animation. We are also not following it with the camera, so on and so forth. So we will start doing all of those things in the next video. And for some reason, I took my game tab. Anyways, we see that that works. And what happens, we already explained this over here. So we already explained how that happens. And when this over here is true, when our transform position X is less than the player transforms X minus 0.5, we will call the takeoff, and you saw the takeoff just happened. So the next step is to create the camera follow player, also to start moving the player forward, so on and so forth. We'll start doing that from the next video. Until then, Fahir here from Masters.com. I'll see you in, well, that next video. Where else can I see you? Take care. Okay, my game developer elves, moving forward, the first thing that we are going to do is set here for our player controller. We're going to create our fixed update, not fixed joint, fixed update like this. And this is a function. Don't worry about this error because we simply need to type here void, and there you go. What the hell is fixed update? Because we have update, we saw that we have late update over here. We explain what it is. Now, fixed update is in comparison to update not called every frame. You see, update is called once per frame, and if we go over here, I believe it was in edit, and I think it's project settings over here, and let me just, why? Like, just why? Unity, why? Okay, there you go. So, I don't know why, but sometimes it bugs when you move from code back and forth, but still it's better than in Unreal when you need to wait for a gazillion minutes. Anyways, time, you see over here, when you go into project settings and you go time, fixed time step is 0.02, which means that every 0.02 seconds, fixed update will be called. So a fixed time interval. And this is where you put your code for physics, okay? So if you're a physicist, if you're learning physics now, you need to have a fixed update at your home to learn physics. Of course, I'm kidding, and I'm very funny. Moving forward over here, we're going to say if we are moving. So only if we are moving, I am going to say my body.velocity is going to be equal to new vector 3. And over here, we're going to set the current horizontal speed, and we're going to say current vertical speed, and we are going to say my body.velocity.z. And over here, we're going to say my body.transform.Euler angles is going to be equal to current angle, not current vertical speed, but current angle, current angle. There we go. What the hell is this over here, teacher? What are you doing this to me? Calm down. Calm down. So my body velocity and velocity is speed over time. So basically, if we use something like this, if we say my body dot add force, this will add force and velocity will increase over time. But if you edit velocity right away, think of it like this. If you have your car and you press the gas pedal, your car speed will increase over time. That is velocity. But if you can edit velocity directly, it's like being able to start your car from 0 to 100 miles per hour in, let's say, 0.01 second or a blink of an eye. So that's what velocity is. So we're setting velocity to be equal to current horizontal speed and vertical speed and my body velocity z, which will propel it forward. And we will see that in a moment. Because what we're going to do is, and also here, this is for the angle, just rotating the plane. And when we start controlling the plane and everything, it's going to be more clear. But what we are going to do next is here inside of our resume, which is a function that we are calling over here in our takeoff animation event. So let me just wait for Unity to come back from its hangover from going from script to Unity editor. So you see over here inside of this animation event, if I select it, so if I can click on it, can I click on it? Let me just zoom in and see. For for some reason, I'm not able to click on the animation event. Anyways, it's not important. Let me select this over here. Okay, now I can, I think, click on it. I don't know what it is, but in the previous video we covered it, you see, but now it's some error. Anyways, it's not important, it will still work, but my point is that when the frame or the animation gets to this point over here, to this animation, and now it works, yay! It will call this function resume, and don't worry about this, you see, now you see it like this. Previously we saw it as a drop-down list. I don't know what this is, it's some kind of error, some kind of bug, I don't know, don't blame me, blame Unity. Anyways, but it will call the resume function inside of this script. So what we are going to do is we are going to say my body.velocity is going to be equal to stored velocity. So let me just go back over here. Stored, come on, stored velocity, thank you. And my body dot is kinematic is going to be equal to false, excuse me, not true. So now we are going to add to it gravity, and our moving is going to be equal to true, which means now this over here will be working. So moving will be equal to true. And our box collider, we are also going to activate all the box colliders that we have on our plane, because I said when we created our character, or when we created the project, when we imported, I told you to take a look at the character, to take a look at the plane and everything that we have. I have these box colliders attached on him. We have one that is a trigger. We have another one that is not a trigger. Yada, yada, yada. You get my point. So what we are going to do, let me just go back over here. As you can see at the top, our stored velocity is equal to new vector 3, and I set here 0, 0 and start speed, which means over here when I set velocity to be equal to store velocity, we will start moving our plane forward, because the forward or the start speed is going to be equal to 40, and over here he will move forward. And over here we also have moving to true, but now we also need to get all box colliders. So box collider, and this is an array, and I'm going to call this box calls, short for box colliders, is equal to get components. So get components, not get component, because it's plural, not singular, and we are going to get the box collider component. Box collider here will be singular because that is the name of the class, or that is built into Unity that represents a box collider. But over here we need to say get components, because it will return an array of box colliders if we have more than one attached on it. And even if you have one, you can still use get components, but you will only have one element in that array. And over here I'm going to say for each, and I'm going to say var b in our box colliders. So in box calls, like this, thank you, finally it works. I'm simply going to see be enabled is equal to true, because if I go back over here, we will see that these box colliders are not enabled. So pay attention over here. We have one box collider, we have another box collider, both are not enabled. So we are also going to enable them, and that's all there is to it. So what this code is going to do is going to set the velocity of my body, of the plane's body, to stored velocity, because over here we have the stored velocity 0, 0 start speed, and it will start moving the plane. So let's test that out and see if it actually works. For some reason I love to clear the console before I hit the play button. So let's see if this actually works, and I can hear our background music. I'm going to hit the play button. So now we are going to see that our plane is going to take off in a moment or two when the animation ends. So you see the plane is taking off, and now when we reach the end of the animation, we're going to call the resume, and you see the plane is moving. You see, he is not stopping. The plane is moving, as you can see. Pay attention. The plane is moving and not stopping. But if I go back over here, our camera is here. The plane went away. Pay attention. The plane is somewhere, or let me just, you don't want to see the time. The plane is somewhere around here. We don't see it. So what we need to do? Well, we need to follow the player. So let's go back over here in our main camera, and right here below our lerp camera, we are going to create a void camera follow player like this. So camera follow player. And this function we are going to call over here. So over here is where we are going to call camera follow player. Now we are also going to have a function that is going to change the camera. So over here below that, we're going to create void switch camera type like this, And simply here we are going to test if our input.get key down, and that key is going to be key code E. So when we press the key code E, we will switch the camera. But don't worry about that. That will come after we first follow the player. So over here, let me just tag this follow player. What's going to happen inside of our camera follow player is that I'm going to say if our camera locked to player, which we set over here to be equal to true. So if the camera is locked to the player, and with an exclamation mark, our camera end screen. So if we don't have the end screen of the camera, meaning the game is not over, and this is again if you want to add the end screen to basically preview the game over and so on and so forth. But if we are locked to the player, we can do it like this as well. So I can say this camera locked to player as well, it will work. But again, over here, this is if you want to add the end screen. So if our camera is locked to the player, and if our camera type, so camera type is equal to 0, so we have one view of the camera. If it's equal to 0, then our transform position, or the camera's position, is going to be equal to new vector 3. And what I'm going to do over here is I'm going to say matf lerp, again I'm using lerp, and I'm going to lerp from transform position x, which is the current camera position x, towards the player dot transform dot position dot x, using or in time dot delta time multiplied by 5f. This is the time interval that we will use to lerp from the current camera position x to the player position x. And let me just paste this one more time because we have x, y, and z. Next, I'm going to say lerp from transform position y, which is the camera position y, towards player's transform position y plus 20f. And again, we are going to lerp in time dot delta time, but this time I'm going to say plus 5f. And over here, as you can see, we're simply subtract or adding to our delta time 5f, and this is again the time interval it will take for us to move or lerp from this position to this position. Now when it comes to transform position z, we don't want to copy and paste this, so my mistake. Instead we're going to say player.transform.position.z minus 80, and this is going to be our transform position z, so minus 80f. Just so that the camera is slightly away from the player on the z-axis, so away from the player, and this is going to be the x position is going to be the same, the y position is going to be a little bit above. And next here below, we are also going to say transform.euler angles is equal to new vector 3, and this is just to rotate the camera. So we are going to use here camera tilt for the x and 0 for the y, 0 for the z. Else, if all of this is not true, meaning if our camera type is actually not equal to 0, meaning it's equal to 1, we are simply going to say transform.position is equal to new vector 3. And over here, I'm simply going to say 250 for the x, 90 for the y, and player.transform. So it's player.transform.position.z minus 120f. And for the Euler angles, I'm simply going to take this, paste it over here, and also say 0 for the x. So we're going to have 0 for the x, 0 for the y, 0 for the z. So what's happening over here? Basically, we are lerping towards the position of the player, which we already explained. We already saw this multiple times. When that happens here at the end, we are going to say game started is equal to false, which means we will stop lerping, and we will say camera lock to player is going to be equal to true, which means it will trigger this over here. So if camera lock to player is true, and we don't have the camera end screen, if the camera type is equal to 0, which we set over here at the beginning or at the top, camera type is 0 by default when we start our game, we're going to set our transform position to the lerping from our current position towards the player position x in time.delta time multiplied by 5. And we're going to lerp from transform position y towards player transform position y plus 20 to slightly make it above the player in delta time plus 5. And it's going to be our player transform position z minus 80 for the z. So we're not going to lerp over there. And simply this is the Euler angle, so the angles of the camera that we are going to set And that's all there is to it. If our camera type is not equal to 0, meaning it's equal to 1, then our transform position is going to be equal to this over here. So rough values, 250, 90, player transform position Z minus 120, and transform Euler angles. And over here, if in our switch camera type, which by the way we are going to call inside the update, so this one is going to be called inside the update function. And over here, we are going to say if our camera type, so if the camera type is equal to, and it's, let me just go back over here, let me find the value, here it is. So if the camera type is equal to 0, then we're simply going to say camera type is equal to 1, else our camera type is equal to 0. It's simple as that. And notice I've omitted curly brackets. Pay attention over here. If after the if statement you only have one line of code, like I do in this case, you can omit curly brackets. So you can type it if camera type is equal to 0, in curly brackets, camera type is equal to 1, else, and also here you can add curly brackets like this, so that can also work. So this goes here, and this removes from here. So this can also work like this, or you can remove these. So you can remove these, and again, it also works because we only have one line of code after the if and else statement. If you have more than one, it will not work. And we will test now to switch the camera type, but this will simply switch the scene view or the view of the camera when we are following our player. But this right here will make it follow the player. So let's go back over here, and if I hit the play button, so now when I play the game, we will see the plane take off. So I hit the play game. Now our plane will start to take off. And when the plane takes off, we will follow the plane along with the camera. Pay attention, the camera is following the player. You see, it is now following the player. And you see he is moving forward. If I press E, pay attention, you see I switch the camera. And again, you see I switch the camera. And here is the plane. We don't see it because of the island. It's the same, it has the same color. But now you see, we see it. And if I switch it, you see, simply switching the view. It's not something wow that I did that nobody else invented before. So simply switching the position of following the player. If something is not clear, please ask in the comment below the video. Until then, here from awesometuts.com. I'll see you guys in the next video. Moving forward with our plane, now we are going to control it because he takes off and nobody is piloting the plane. So right here above our takeoff, we are going to create first void move right. And this one is going to be for moving right, of course. So we have move right. And here, what I'm going to do is I'm going to say current angle is going to be equal to new vector 3. This is when we press the A, or actually the D key, because we are moving right. And here I'm going to say matf.lerp angle, and we are going to lerp from the current angle x towards 0 in time.delta time. Now this is for the x, and let me just take all of this and copy it, put comma over here and paste it, put comma one more time and paste it, so that we have x, y, and z. So over here we have the y angle, so again we're going to lerp from our current y angle towards 0 in time.delta time, and we are going to lerp from angle z towards negative 70 in time.delta time interval. And now I can take this back over here. When I said take this back, put this bracket, bracelet, whatever you're going to call it, in semicolon in this line. That's all there is to it. And this is for the current angle. Next, we are going to say current horizontal speed, because over here, if you remember, when we are moving, the velocity is equal to the current horizontal speed and current vertical speed. So current horizontal speed, I'm going to set that to go from matf, and it's going to lerp from the current horizontal speed towards the maximum horizontal speed plus the bonus horizontal speed, and all that will happen in time.delta time. Now let me just take this over here and put it on another line. So there you go. So the current horizontal speed will go, or it will be equal to, we're going to lerp from the current horizontal speed or its value towards the maximum horizontal speed plus the bonus, and the bonus will be added when we add that boost bonus, which we will see later on how to do. So move right. This one is for moving right. Now I'm going to simply copy this whole function and paste it below because we're going to do the same thing for move left. So over here we're going to say move left, and over here it's also move left. And what's going to happen for our move left is that we're going to lerp for the angle, the current angle. We're going to lerp from current angle x towards 0, from y towards 0, from z towards positive 70. So not negative, but positive 70. And we're going to say the current horizontal speed is going to go from the current horizontal speed towards the negative, so negative of the maximum horizontal speed plus the negative bonus horizontal speed. But over here, we're also going to say plus the negative boost. So over here, I'm going to say plus the negative boost horizontal speed. And by the way, we're going to do the exact same thing here. I forgot to do that, so sorry for that. So we have plus the bonus horizontal speed plus the boost horizontal speed. And again, these two will be checked later on when we add the boost. But over here, we're going to lerp from the current horizontal speed to negative maximum horizontal speed plus the negative bonus plus the negative boost horizontal speed. And why negative? Well, because we know this is the coordinate like this is y, this is x. Towards the right side is the positive, towards the left side is the negative. So when we go to the left side, that's the negative side. That's all there is to it. Now let me just copy this over here and go below and paste it because this one is going to be move up. So over here we have our move up. And here I'm also going to say move up instead of move left. So type here move up. And we are going to lerp from the current angle x towards the negative 35. So let me just go here. Current angle is equal to, we're going to lerp, vector 3 is going to lerp from current angle x towards negative 35. So here negative 35, there you go. And for the y, we're not going to lerp at all. Instead, we're going to simply say current angle dot y. And for the z also. So let me just take this over here, remove it like this, and here current angle dot z. That's all there is to it. So we're just lerping on the x-axis. And moving forward, what I'm going to do for our current vertical speed, so we're going to remove this from here. So we're going to say current vertical speed, that's going to be equal to, we're going to lerp matf lerp, and we're going to lerp from the current vertical speed towards the maximum vertical speed in time dot delta time. We're going to divide that by 2f. This is going to be our time interval in which we are going to lerp. And let me just take this over here and paste it. So copy and paste it. This one is going to be moved down. So move down, and also here it's going to be moved down. So simply what we're going to change is that we're going to lerp from the current angle x towards the positive 35. And then we're going to have here current angle y and z. That's going to stay as is. And here we have the current vertical speed. And that's going to go from the current vertical speed towards the negative maximum vertical speed. That's all there is to it. If something is not clear, please ask in the comment below, but this is all clear. This should not be confusing at all. We were just lerping. We explained what is lerp and what is lerp angle. And we're just lerping those values to gradually go from one point to another so that we don't go straight like this. Instead, we go gradually like this and it's smoothened out. It's not like this, you know, you get the point. And this is basic calculation, so this is nothing complicated at all. Now, moving forward, we are going to, below this move down, we're going to create void keyboard input. This is to get the keyboard input from our user, and we're going to call this one in the update function. So going here, update, call it. And this is for the input that we are going to control our plane. So what's going to happen over here is simply we're going to test if we are moving. So if the plane is moving, then we will be able to get that input from the user. And simply here we're going to say if our input dot get key, so get key, and that key is going to be equal to key code dot a. And if that is pressed, that means we are going to move left. So here we're going to say move left. And I'm simply going to copy all of this like this and paste 1, 2, and 3. And next we are going to test here if the pressed key is D, then we're going to move right. So we're going to say move right. Here, if the pressed key is W, we are going to move up. So over here, it's going to be moved up. And lastly, if the pressed key is S, then we are going to move down. So move down. Not move up, but move down. There we go. One thing that I want to point out is pay attention over here, and let me just go here and change to the Unity editor so that it loads the script and whatnot. One thing that I want to point out is pay attention. Here I'm using get key, but over here for the camera, for our switch camera type, I'm using get key down. What is the difference? Get key down, if I hover over, returns true during the frame the user starts pressing down the key. So only during the frame, when we press this key that we provided here as a parameter, in this case it's E, that is when we will detect this. But over here for get key, returns true while the user holds down the key. So as long as we are pressing and holding down the key specified here, which is W in this case, this will return true. And I want you to test it out. Use if input get key and if input get key down, and use the print statement to check it out, what you will see, so that things will get clear to you. So moving forward, let me go back over here. If I hit the play button, let me just lower my volume so that we don't hear the background music. If I hit the play game, now our plane is going to take off. And pay attention now, I'm trying to move my plane or actually control him left and right, up and down. It's not working because we are not moving until we go to the last frame in our game, and now we are able to control him. But pay attention, we have one issue because you see I just pressed it one time and it still works. You see, you have to control your plane like this. I'm not pressing anything right now, but the plane is going, and we don't want that. What I want is to press left one time, and then when I release it, he will stop. And also for the right, and so on and so forth. You get the point. What's important here is that we can control our plane. Also our propeller, or whatever this is called, at the front, that should be rotating. We will fix that later on, don't worry about that. But over here, what's important is that what I want is when I press I'm currently pressing the A key, you see, and now I have released it, but the plane is still going. I don't want that. I want to strict that. So when the plane is not going, and also I want to set the bounds for my plane so that the plane is not, going outside of bounds. But you can also leave controls like this, but I will show you how to fix this starting from the next video. Anyways, if something is not clear, fire here from monsters.com. Something is not clear, it will not be clear, just kidding, but ask in the comment below, and I will see you guys in the next video. Let us now correct the player's movement, and you will see what I meant when I said that. So let's go over here below or above the start takeoff, and we are going to create here void check control input. This is how I am going to name the function. So over here, control input, and what's gonna happen inside is that first we need to check if we're actually moving. So if moving, because this only happens if we are moving. If we're not moving, why are we going to strict the movement? And here, if our input, so here, if the input is not equal to get key code dot D, so we're not pressing the key code D, and our input dot get key, we're also not pressing key code A like this. So notice over here the exclamation mark. The exclamation mark will make what's after the opposite. If input get key code D, that means if we are pressing the key code D, this will return true. If we are not pressing, it will return false. So in this case, if we're not pressing the key D and we are not pressing the key A, both will return true. And in this case, both of these need to be true for this if statement to evaluate to be true because of this right here. If you don't know that, then you need to watch my basic C# tutorials that I also have in the Game Development Academy. Anyway, if that is not true, we are going to say, basically just think of this here. If we are not pressing key code D and at the same time we are also not pressing key code A, we are going to say here current horizontal speed. So current horizontal speed, that's going to be equal to matf.lerp, and we are going to lerp from the current horizontal speed towards 0 in time.delta time divided by 0.1 f. And again, if you're wondering, how do I know these little numbers, what I do with them, yada yada yada, this is all experimenting. So this is all experimenting. So you try to put here number 100 and see if that works. Try put number gazillion, see if that works. Then you put 0.1, if that works, you use that, so on and so forth. That's how it works. So let's go over here, and what I'm going to do, and what did I press? So over here, 0.1 f. let me just go back up and take this. So I'm going to take this, copy all of that and paste it here. So our current angle, and this goes here like this. So, and the current angle is equal to new vector 3, and I just copy paste it because I don't want to type it out, you see it's tedious. So the current angle is gonna be lerping from current angle x towards the current angle x in time dot delta time. The angle y is gonna be lerping, or it will lerp from y towards 0 in time dot delta time, and the angle z will lerp from current angle z towards 0 in time dot delta time multiplied by 2f. That's all there is to it. Let's go back below, or let's go below, and here we're going to say if, but basically I can just copy and paste this. So I can copy this and I can paste it, because over here we are going to test if we're not pressing the key W and we are not pressing the S key, then our current vertical speed, so current vertical speed is going to be equal to, and we're going to lerp. So we're going to lerp from the current vertical speed, so current vertical speed towards 0 in time dot delta time divided by 0.1. That's all there is to it. And again, we explained what is lerp. It's going to go from this value towards this value with this time interval. Next, our current angle is going to go from current angle 0 and here, or actually current angle x towards 0 in time dot delta time multiplied by 2f. Here, mat f lerp angle is going to go from current angle y towards 0 in time dot delta time, and over here we're going to go from current angle z towards the current angle, so it's actually current angle z again, and over here we are simply going to use time dot delta time instead of multiplying that by 2. That's all there is to it. And I need to add one more bracket or bracket. What's this called? Bracket. Open, close. Parentheses. Not bracket. Parentheses. Sometimes I forget. Anyways, it's not important. So what we're going to do is take the control input and go over here at the top and call it above the keyboard input. So call it above. So let me just go over here and open the editor so that it can, load everything. But basically what we're doing, again, we're testing if we're not pressing key code D and key code H. So at the same time, we're not pressing either of these keys. Then we're going to go with the current horizontal speed back at 0 by lerping, and for the angle as well. And over here, we're doing the exact same thing, but we're going from vertical speed towards 0 and for the angle as well. So what we need to do, we need to go back in Unity and test it out. You saw before what happened with the plane. So I simply pressed the key and the speed was applied the whole time, even when I released it. But now, when I release the key, the speed will not be applied to our player anymore. So pay attention now. If I start moving, so if I can move, you see now when I release, you see? Again, I release the button, bam, and I'm going down, I release the button, you see? Going up, release the button, you see the difference. So again, I'm not going to repeat myself and yada, yada, yada. Just go back here in the code, and what you can do is comment out this line of code. So remove it so that you can test out, again, the movement without. So you can test out the movement without that function, but basically it tricks the movement. You see, it tricks the movement. And pay attention now when I press E to change the camera. So now we see better because now we can control the plane and we see better. Now, one thing that I want to do is strict or create the bounds for the player, because now he can go outside the camera, he can go below the camera, as you can see, and this is not something that we want. So we need to create bounds for our player. So I'm going to turn off and go back over here in our code. Let's go below our control input, and over here we're going to create void check player borders. There you go. And over here we're going to say player border like this. And what I'm going to do is copy this and not do this. By the way, if you're wondering how am I doing this, I'm holding control and moving forward and backwards my wheel on the mouse. So moving forward, it will you see, it will make the letters and the font bigger. And let's go here at the top, or actually in the update, and call our check player borders. And again, it's in the update. You see check player border, check control input, and keyboard input. So let's go back in the function. Again, what we need to do. We first need to test if we're moving, because everything happens when we are moving. We cannot test all of these things if we are not moving. So what we are going to do over here, we are going to strict the player on the X and the Y axis. So first I'm going to say if the transform.position.y, Y, not X, Y, give Y. Anyways, I'm not going to, argue with the computer. So transform.position Y, if that is greater than the vertical upper limit, this is the bound for the vertical upper limit. If that is true, then we're going to say transform.position dot, or actually is simply equal to new vector 3. So transform.position is equal to new vector 3. Transform.position dot x, we're going to leave that. And for the y, we're going to say vertical upper limit -1. And for the z, it's going to be transform.position dot z. That's all there is to it. The current vertical speed is going to be equal to 0. And here I'm going to say input dot reset input axes. What the hell is this, teacher? I don't understand. Calm down, man. Calm down. Don't be crying. Don't do anything. Input reset input axis. You see, resets all input. After reset input axis, all axes return to 0, and all buttons return to 0 for 1 frame. So in the frame where we catch our player, his position X to be actually Y to be greater than the vertical upper limit, we're going to reset his transform position. So X is going to stay the same, Z is going to stay the same, but our vertical upper limit, or Y, is going to be equal to the upper limit -1. This is if it goes above the Y upper limit. So basically, if our upper limit is here and the plane tries to go over here, we're simply going to set his Y to be over here, because this is the upper limit over here, -1, that will be this position. This is approximately not 100% accurate. And then we're going to reset the speed and input axis so that we, don't try to move him up during that frame again. So next, I'm going to simply copy this and go below and paste it, because now if the transform position Y is less than vertical lower limit, we're going to do the same thing. So transform position is going to be equal to new vector 3. The X is going to stay the same, but vertical, or the Y is going to be vertical lower limit, but +1. The Z is going to stay the same, and we're also going to reset the axes and the vertical speed. And why vertical lower limit +1? Well, lower limit is here. If the plane tries to go below it, we're going to allow it to be over here. This is the limit, vertical lower limit +1, which is approximately here. So above the vertical lower limit. I'm going to paste this one more time, or actually this, not the vertical lower limit. So I'm going to paste this. And over here, we're going to test if our transform.position X is less than the horizontal or left border limit X. So if the transform position X is less than the left border limit, we're going to position that, and we're going to lerp again. But this time, the X position is going to be edited. So it's going to be at left border limit +1. And over here, we're going to say transform.position.y. Here, we're going to reset the horizontal speed. So current horizontal speed will be reset to 0. You see, current horizontal speed reset to 0, and also reset input axis. But before that, we're also going to edit the current angle. So we're going to say current angle, and that's going to be equal to new vector 3. And over here, I'm simply going to say matf.lerp angle, and we are going to lerp the angle from the current angle.x towards 0 in time.delta time. And let me just copy this. So matf, there you go, comma. Then we are going to lerp the current angle y towards 0, again, in time.delta time, and we're going to lerp the current angle z in time.delta time, but we're also going to multiply that by 2. And then we are going to reset the input axis. So this is the only difference what we did in regards to the vertical or on the y-axis and on the x-axis. So we are also going to reset the current angle when we reset or not allow the player to go above or to the left side from the left border limit. And again, for the x over here, we're saying left border limit x plus 1, which means if the border is here, we're going to say plus 1, which means a little bit outside the border. So I'm going to copy this again and paste it one more time, which is going to be the last time. And over here, we're going to test if our position x is going to be greater than the right border limit x. So if the transform position x, our current x, is going to be greater than the right border limit x, over here, we're going to say transform position is equal to new vector 3, right border limit x, but we're subtracting 1 to make it not go outside that border. Transform position y and z are going to stay the same. Current horizontal speed is going to be reset to 0. The angles are also going to lerp from the current angles x, y, and z towards 0, and in the time.delta time for x and y, and time.delta time multiplied by 2 for the z-axis. And then we're also going to reset input axes or axis. That's all there is to it. And we're of course calling this in the update function. So now if I go back over here, and we do need to wait a moment or two or eternity for Unity to load the script, and it loaded, hit the play button. So now when I press the play button, come on, here it is, play game. So now when we start to play, you will see that I will be able to limit the movement of the plane. So now if I try to move, I'm gonna hold the right key. You see, and this is, you see how it's like lagging? It doesn't allow me to go above that value. And here also, and up, you see up, again, it's not allowing me. And you can see that clearly over here when I reset the camera. You see now, I'm trying to go even further down, but it's not allowing me. Now I'm still pressing the button. You see at the top, you see how the plane is like, you know, glitching and stuff like that. So if I try to move to the right, again, you see, and let's try again to move to the left side, and we have restricted the movement of our plane. There you go. Wee. And basically that's it. So if something is not clear, please ask in the comment below. Until then, fire here from awesome.com. I'll see you guys in the next video. In this short video, we're going to make the propeller, whatever this is called, I don't know, this thing over here on the, you see this? We're going to make it rotate on our plane or player, however you want to call them. Anyways, let's go over here in the player scripts. I'm going to right click and create a new C# script. I'm going to call this one Propeller. This is apparently the name for this thing. Anyways, I am going to select, so let's go over here, and basically what you need, select the transport plane you see over here, and it's this thing, box 333, and attach this propeller or whatever on the box 333. This is the script, okay? And what we're going to do over here is we're simply going to create a private bool, and it's going to be called rotating, and by default I'm going to set this bad boy to be equal to true. And we don't need the start function, we only need the update. And over here in the update, we're going to say if rotating, so if that is true, then we are simply going to say transform.rotate, and we are going to rotate at vector 3 right, and we're going to multiply that by 40. That's all there is to it. Now below, I'm also going to say public void, so public void pause rotation, and here we're going to say rotating is equal to false, and over here I'm going to create public void resume, so we're going to say resume rotation, and over here I'm going to say it's equal to true. Now for what I'm going to use these is, and let me just go back over here so that Unity loads the script. If for some reason in any case you want to, you know, make the propeller go in the resume over here, you can then get a reference to it, and you can call resume, and you can call pause in order to pause the rotation, and yada yada yada. You get the point. But basically this is all there is to it. Simply create a bool variable rotating, and if that is true, by default it is. Then the transform rotate, if I hover over, well, you can look this up, but basically this will rotate the transform of this game object, and I'm going to rotate it in the right direction, multiply by 40 to smooth it out. And even if I simply just run the game, we will see now, if I go in the scene view, you will be able to see, I'm not sure if you can see it from here, but here it is, pay attention, it is rotating. If I go into scene view, you see it is rotating, and there you go. So now if I hit the play button and our plane goes, this is rotating, yada yada yada, you get the point. We have a feeling like this is a real plane and we're piloting it, and you know, you get the point. That's all there is to it. You see, now we can move left and right, up and down, and there we go, a real plane. So if something is not clear, but basically there is nothing that should not be clear in this short video, ask in the comment below, and until then, Fire here from Asdos.com. I will see you guys in the next video. Moving forward, my developer elves, next we are going to start respawning these islands when we pass by one. So you saw in the preview of the game, the first video, if not, go back and see it. But when we pass this island, we will respawn a new one in front of the player. And in order to do that, in the scripts folder, right click and first create a folder that we are going to call gameplay controllers. So it's controllers, there you go. And inside of this bad boy, we are going to right click and create a C# script, and we're going to call this bad boy spawner. Now, before I do anything, let me just go back here in Unity, and here in the hierarchy, I am going to create an empty game object that I'm going to call a spawner. So spawner, come on, is it going to work? Unity is lagging sometimes. I thought Unreal is bad for this, but Unity is also bad. So, but maybe it's my computer, so I cannot judge, okay? I'm not judging. Don't judge me. So let's go over here in the spawner script, and what we are going to do inside of the spawner is we are going to prepare everything that we're going to spawn. That includes enemies, collectible items, and islands as well. Now, what I'm going to do here is, first things first, we are going to create a public static spawner, which is instance, and in the awake function we're going to say if the instance is equal to null, then we're going to say instance is equal to this, like this. It's equal to this, like this. So what this is we created an instance, and we talked about singletons. I've explained that gazillions of times in my courses, and I have a special video on my YouTube channel where I only explain singletons. So if you're not sure what that is, go and watch it. But basically this will allow us to call the static instance from the spawner and then call all public variables that he has inside of him, so inside of this class. And I'm also going to remove this as well because we're not going to need it. And below we are going to declare a private list of game objects, and this one is going to be island pool, island pool, which is going to be equal to new list of game objects like this. And I'm also going to simply copy this, and this is Island records. If you watched Big Shack, I'm hoping that you did, so you understand the joke. But anyways, this is going to be our enemy plane pool. So this is where we're going to store our enemies. Next, we are going to have our clouds pool. Next, we are going to have our pick up pool, and this is not a pool where you can actually, you know, take a bath or whatever. And balloon pool, there we go. And actually we will need the start function, so, or I can do that in the wake. So yeah, I can do that in the wake as well. So right here below our instance where we declare the instance, and again, a list is like an array. We covered this, so please, if you're at the beginning, you don't understand these things, then you need to rewatch some other course. Go back in my academy and see the guidelines, which is the first course that you need to follow to be able to understand all this, so that I don't explain everything every single time in every course. So we have a list, which is an array of game objects, and over here we are going to, and let me just tag the awake function, so awake, and here we're going to create all of these variables. So first things first, I'm going to say here object array, and that's going to be equal to list, or name it list, and that's going to be equal to resources dot load all. And what the hell is resources, and what the hell is this load all? And here I'm going to say islands, island records. So teacher, what the hell is the resource? Calm down, man, calm down, don't cry, okay? Resources is a class that allows us to load anything with the call of a function from a folder called resources. But over here, you need to create that folder resources. I already did that, and pay attention over here. You see, I have the resources folder, and notice what I'm doing. Load all, and I'm giving islands. And if I hover over, you see, pay attention, loads all assets in a folder or file path in a resources folder. So that means inside of this resources folder, there is a folder called islands, and here it is. And inside it will load everything. So it will load island 1, island 2, island 3, yada, yada, yada. You get the point. You get the point. So it will load all those islands. And again, resources, but that is inside of the resources folder that we need to create, but I already created that for you, and it will load those, well, islands. Also, one thing over here that I forgot to do is pay attention. I forgot to remove the scripts that I have prepared in the previous video, previous project where I prepared this project. So what you're going to do is select this prefab over here, click on open prefabs, and you're going to remove this script. You see, pay attention over here. You see you have the script, you're going to remove it. So simply remove the script, that's all there is to it. And let me just go back and select island 2, go over here, also remove the script, island 3, open prefab, remove the script, and also island 4, because again, I forgot to remove the script like this from the prefabs, and they don't have it, so yeah, that's all there is to it. It's nothing, you know, just sorry for the extra work. That's all. So again, you are going to do that on your own. Let me just remove from this one. Do that on your own. I'm not going to do that. And also, I believe we have here on our enemy plane. Yes, we have on our enemy plane, as you can see. And I believe that we have also on the balloons. Do we have? Yeah, on these prefabs over here that we are going to use. So we're going to use the prefabs from the pickup, from enemy air, clouds, and balloons. So make sure that you remove these scripts that are missing by simply opening the prefab and over here locating where the script is and removing it. That's all there is to it. So a little extra work, but sorry, you know, it's not a big deal. Moving forward. So here we are going to load all these objects, or everything that is located in the folder islands. We're going to load that inside of this list. And next, what we are going to do is we're going to say for int I, which is going to be equal to 0, as long as I is less than list.length I++. So we are going to loop inside of this list for the length of the list. And I'm going to loop again. So I'm going to say for int j, which is going to be equal to 0, as long as j is less than 3, j++, so I'm going to loop 3 more times inside of this loop over here, and I'm going to simply say here game object, and I'm going to name it obj is going to be equal to, I'm going to get that from the list, so I'm going to get it from the list at the element I, but we need to cast it into a game object. So I need to say here game object like this. Why do I need to cast it? Because I'm getting it as an object. So I'm simply getting it as a regular object. And then I need to cast it into a game object. This goes back to inheritance, or yeah, actually goes back to inheritance and object-oriented programming. If you remember, I have a player and then we have a knight. When we talked about that in the C# section, and every knight is also a player. Well, in this case, the object is the player, but it's also a knight, but we got it as a player, so here we're casting it into a knight. Again, if it's not clear, go back and rewatch those videos. Next, we are going to say obj.setActive, so obj setActive is equal to false to deactivate that game object because we don't want to activate it right away. And then simply we're going to say island pool add, and while we are adding that game object, we're going to instantiate. So instantiate. And we are going to pass over here obj. And instantiate will simply create a copy out of that object. So basically what this here means, let's say in this list I have 4 elements, which means this loop is going to loop 4 times. And for every 4 times that it loops, this here will loop 3 more times, creating 3 objects. So in total, this will loop 4 multiplied by 3. It will create 12 of these objects that we are going to store inside of this island pool list. This is what we are doing here. And here I'm going to say create islands. So create islands. That's all there is to it. And here I'm also going to say create islands like this. Just so that we know that this is actually for creating islands. Because I'm also going to copy this and we are going to paste it below. And we're going to use this for clouds. So over here, instead of islands, I'm going to say clouds. And we are going to remove this obj list or simply object, and we're going to use list. And over here, we are going to say clouds. And over here, everything else is going to be the same as list.length. That's how many times we're going to loop. But over here, for j, we're going to loop 15 times. So we're going to loop 15 times more. Create this, set active false, but here not island pool, it's going to be our clouds pool, and we're going to add that to the clouds pool. So basically the exact same thing, the exact same process. This is nothing like, it's the same, the explanation is the same. Let's say here we load all resources inside of the clouds folder. If I go over here, this is our clouds folder, and make sure, you need to make sure one thing, so make sure that you don't have any typos. The name you pass here, so clouds, capital C L-O-U-D-S, that needs to match up here. So capital C, capitalization is important. If you have lowercase c here, but you use capital C here, it will not work. So capitalization needs to be in order. And everything else. So inside of clouds, we have all of these clouds, as you can see. And again, make sure that you remove the missing scripts. And we have all of these clouds. It will load them here. Next, let's say this list has, so we are using list.length. That means how many elements is inside the array. Let's say it's 10 elements in the array. So we're going to loop this 10 times, and for every 10 times that this loops, this will loop 15 times more. And we will create that many objects. So basically it will be 10 multiplied by 15. That means we will create 150 of these objects over here. That's all there is to it. And make sure that you're adding these to the correct pool, so clouds pool. Because we are copying and pasting this, the code is exactly the same, so I don't want to retype it again. There is no need to do that. So I'm going to paste it over here. Next, we are going to have our enemy planes, so create planes over here, and here planes, and instead of clouds, we are going to say enemy air. List.length, everything is cool over here, except here we are going to say int j is 0 as long as j is less than 5, so we're going to loop 5 more times. And going back here, it's not going to be the clouds pool, but the enemy plane pool. That's all there is to it. We're also going to do the same thing for balloons and pickups, so copy this and go back and paste it, and here I'm going to say balloons. So it's balloons instead of planes, and here instead of enemy air, we're going to say balloons, and everything is going to be the same, list.length, and here we're going to loop j 5 times, game object obj, we're going to get that from the list, which is inside of, well, this list over, or actually this list over here, the element that's at I index, currently in the loop. Obj set active false, and over here, we're going to say balloon pool, dot add and instantiate a new object. And last but not least, we are going to do the same thing with our pickups. So over here, instead of balloons, we're going to say pickups. So pickups like this. Let me just copy this, paste it here. Instead of balloons, we're going to say pickups, capital P, capital U, pickups. And here the J is going to be 10. So we are going to loop 10 more times in the second loop, adding 10 more elements every single loop inside of the list. And here, not balloon pool, but pick up pool. There you go. And that's all there is to it when it comes to creating these resources. So we created everything, and that's totally fine. But next, we need to create functions that we're going to use to get individual items from those lists. So for example, here we're going to first create a public game object, get pooled island, and over here I'm going to say string, and I'm going to say island name like this, because we're going to pass a name. So get pooled island, string island name. What we are simply going to do, we are going to say game object pooled island is going to be equal to, and we're going to say island pool dot find, and here I'm going to say I greater than, or actually equals, and then greater than sign, I'm going to say I dot name is equal to island name, and here we are going to say with an exclamation mark I dot active in hierarchy. So active in hierarchy. What the hell is this, teacher? What are you doing? Well, calm down just a second. And here we're going to say return pooled island. There you go. Now, what the hell is this right here? I believe this here, and when I say I believe, because I am very bad at memorizing names, what a certain thing is called inside of programming or whatever, because I don't care. What I care is understanding how that works. But this is called a lambda expression. And what this here does, it will simply go inside of this list and it will find us an object with the name, and if that name is equal to the name that we pass here, and it will also tell us if that object is not active in the hierarchy. So basically what we are doing, we are searching for an object that has this name and it's not active in the hierarchy. Why not active in the hierarchy? Well, let me show you right now. So if I go back, pay attention over here, every single time, so let's go, every single time we create a new item or a new object that we're going to add in a certain pool, be that pickup pool, balloon pool, enemy pool, you get the point. We use instantiate. Instantiate will create a copy of the object that we pass it as a parameter. So it will create a copy, which means that object will be inside the scene. So if I go here, we add the spawner. You see, pay attention, we have the spawner. We added that spawner inside of our game hierarchy. We added his script. If I hit the play button, the spawner will create all these objects. So pay attention now inside of the hierarchy. Look at all these objects. These are all the objects that we have created. Look at all these. And this is because of instantiate. You see, this is because of instantiate. Again, don't forget to remove all the scripts missing from these folders over here that we are getting. Pickups, balloons, enemy air. You get the point, okay? So that's why we are testing if it's not active in the hierarchy. So again, find, and over here I greater or equals and then greater sign, I name. So we're searching for an object I, and if the I's name is equal to island name, and if that island is not active in the hierarchy, and it will return that island. And why I? Well, basically over here you can add any name that you want. You can say P, for example, and over here also change it to P, and over here also change it to P, and well, that will work as well. So it will be P dot active, and it will work. So this name over here, I or P or whatever, it's not that you need to add I. You can add whatever you want over here. So you can say island as well, and then island name, and you get the point, okay? So that's all there is to it. Next, moving forward, this is to get the pool island. Next, we're going to get the random cloud. So here I'm going to say public game object, and this is going to be get random pooled cloud. And this is to get our clouds from the cloud pool. And over here, I'm going to say int cloud. So cloud choice. Cloud choice is going to be equal to, and I don't know how to spell it, it's going to be equal to random.range, like this, and it's going to be from 0. So the range from 0 to clouds pool, so clouds pool dot count, which means how many elements we have in the list of our clouds. So it will get us a number between 0 and clouds pool count minus 1. So this one is inclusive, this one is exclusive. Exclusive meaning it will not use exactly this number. So for example, if it's between 0 and 10, it will get you any number between 0 and 10, not including 10, which means 0, 1, 2, 3, 4, 5, up to 9, not including 10, okay? Next, I'm simply going to say here while, and here we're going to say clouds pool, so clouds pool, and the element that's at the cloud choice, so the element that's at the cloud choice index, active, so dot active in hierarchy, actually active in hierarchy, come on, thank you. So while the clouds pool and the element that's at this index, because this is an array, and while that is active in the hierarchy, we need to try and get another cloud because we don't want to get the same cloud that is already active. And then simply what we are going to do is return the one that's active. So return, or actually the one that's not active, return clouds pool and this bad boy. So you see over here, we are generating a random index to get the element at that index. While that element, which is at that index, is active in the hierarchy, generate another random index until we get an element that's not active in the hierarchy, and then we will return that element because we don't want to get the element that's already active because that element is in use, okay? And we will see all this later on. Next, we're going to say public game object get pooled enemy plane, and here string enemy, so enemy plane name like this. And this is going to be the same thing, so we're going to say game object plane is going to be equal to enemy plane pool dot find, and over here I'm going to say p for plane and equals greater than sign p dot name if it's equal to enemy plane name, not pool but name, and if the P is active or active in hierarchy. So if it's not active in hierarchy, and then simply return the plane. So again, we are finding inside of the list, find me a plane which has a name, enemy plane name, that we pass over here, and that plane is also not active. Notice the exclamation mark. It will make what's after it the opposite, which means if this returns false, this will make it the opposite, which is true. So, and it's not active in the hierarchy. That's all there is to it. Next, we are going to say here public game object, and we are going to get, or actually here, excuse me, we're going to say public list, and we're going to get a list of game object. This one is going to be get pooled enemy plane pool. So get pooled enemy plane pool. There you go. And simply here we're going to say return, so return enemy plane pool. Why? Well, because later on, if you want to pause the game and you want to, deactivate all the enemies' movement, you can do that by getting all the enemies inside of the enemy pool. That's all there is to it. Next, we are going to have over here a public game object, meaning it returns a game object, get pooled balloon. So get pooled balloon, and it's with double O, so it's BALLOON. And basically same thing. So here game object balloon is gonna be equal to balloon pool dot find, and over here simply we are going to say if the balloon greater equal sign, and simply going to give me the balloon that's not active in the hierarchy. So I simply want that. So find me a balloon that's not active in the hierarchy and return that balloon. So return balloon. That's all there is to it. And last but not least, public game object get pooled pickup. So pooled pick up, and here stringed pick up name like this. And you already know what we're going to do. We're going to say game object pick up is equal to pick up pool find, and we're going to say here p for pickup and equals greater than sign p dot name is equal to pick up name, and our pickup is not active in the hierarchy, p active in hierarchy, and simply over here return pick up. So this all here, what we did is nothing new. These concepts are not new that we just covered them. If you went, of course, through at least one of the courses, the beginner one inside of my academy, if you went straight to this course, then maybe this is new for you. But again, I already explained. If you don't know, you need to go and rewatch the basic stuff. So we created a list of all game objects, enemies, pickups, whatever that we are going to use and have inside of our game. And then we created an instance out of our static spawner. Then we loaded all those objects from the resources folder. We explained what that is. Of course, if something is not clear, please ask in the comment below and I will answer it. And then we created functions that that are going to return one by one. So here we're going to get one island and we explain what that here is. Also for the cloud, same thing, we explain what here is or the code that we wrote, and yada yada yada. You get the point. Everything here should be clear. If it's not, please ask in the comment below, but we prepared our spawner so that he can start giving us all the objects that we want, and from the next video we will start spawning the objects, we will start spawning the island and see how that goes and so on and so forth. Again, don't forget to remove the scripts that are missing. So go back and from all these folders that we load, these objects, clouds, enemy, air, balloons, pickups, you get the point. Remove the scripts that are missing, and I will see you guys in the next video. If you like this course, you can get full access to this and over 50 other courses inside my Ultimate Game Development Academy for a small monthly fee. Link is in the description below.